Hello dear students. So today we will continue our discussions on cloud morphology. We have seen how clouds form, or what is the importance of lifting condensation level in the process of formation of the clouds. We also seen how to identify different types of clouds, how the naming system has come into existence, how the height of a particular cloud and how the shape of a particular cloud are combined to give you the specific name to identify a certain type of a cloud. We have seen all this. Today's class we will try to understand the secondary classification of clouds or the cloud naming system, and we will also try to understand the fundamental process by which fog forms, or how many different ways fog can result. We can also understand the formation of cloud droplets, what is the necessary condition for the formation of cloud droplets, stuff like that. So this lecture is the continuation of our understanding of cloud morphology, lecture 1, right. So secondary classification of clouds is basically is based on the altitude of occurrence. So we have seen the low clouds which lie below 6,500 feet, that we have cumulus, cumulonimbus, stratus and stratocumulus. We also seen that we associate a particular suffix which is called as the nimbus only for those types of clouds which can result in the formation of reasonable amounts of precipitation, right, and stratus and stratocumulus. So stratocumulus clouds are usually formed from the stratus and cumulus clouds. So we have seen stratus clouds are the ones which you see as the layered clouds, as a layered clouds, and cumulus clouds are the white puffy clouds that you see, are generally called as the cumulus clouds. So when you combine them, you can get to see what is called as the stratocumulus clouds. These are generally found within 2,000 to 6,500 feet. They are seen everywhere. So in the earlier class, we have seen what are stratus clouds and what are cumulus clouds. So in the secondary classification, we are able to see that what are the different types of clouds in the low altitudes, that means below 6,500 feet. So one of that is the stratocumulus cloud. So it is a very commonly seen type of cloud that you can see anywhere. Precipitation is occasional. You do not expect heavy rains if you see this type of cloud in the sky, right? And they are mainly composed of water. So that means that depending on the altitude of occurrence, of course, the content is already decided. That means what can be the primary content? I mean, is it going to be water or is it going to be ice, right? Then the mid-level clouds, apart from the low-level clouds, you also have the mid-level clouds, which are Altocumulus, Altostratus and Nimbostratus, right. So here you see alto, which indicates the height, which are upper altitude regions, and Nimbostratus, nimbo means the moisture content, right. So for example, Altocumulus, they form due to the mid-level atmosphere and wave propagation. So this is how they look like, the altocumulus clouds, how they look like. So they form due to the atmospheric wave propagation. So waves such as gravity waves or propagating waves will result in the formation of this type of clouds. So they are seen in the mid level of altitude. So we cannot say that it is mid altitude, rather it's mid range altitude for the clouds formation. So it generally results in 6,500 to 18,000 feet. So we have seen 6,500 to less than 6,000 as the low level clouds, stratocumulus, stratus, we have seen stratus, cumulonimbus, right. So here one more important thing that I have forgot to mention, stratus clouds, we have also seen the stratus clouds by the basic shape of the cloud. Cumulus cloud we also seen, and cumulonimbus cloud doesn't generally confine to one particular height. It spans the entire altitude ranges of the clouds. It's from the lowest of the low to the highest of the high, right. So this only other type of clouds is the stratocumulus cloud, and when you bring in mid heights, mid-level altitudes, we say that the altocumulus is the one, so which can be seen worldwide. You can see it everywhere. Precipitation is light rain, it's not so much, and they are mainly composed of liquid water, right. And the altostratus, so the next type of cloud is altostratus. Altostratus clouds generally form from 6,500 to 23,000 feet. is altostratus. So, we have seen what is a stratus cloud. Stratus cloud is like a layer which is generally found in below 6,500 feet. If this cloud rises further up by any mechanism, this will result into the formation of altostratus clouds. So, usually they are formed from the thickening and lowering of the cirrostratus cloud on its way to becoming a nimbostratus cloud. And they are to be seen everywhere, worldwide occurrence. You can see them to be occurring everywhere, and mainly at the mid latitudes. Mid latitudes are the places where you can find altostratus clouds. Precipitation that you can expect from this type of cloud is occasional rain and snow, because they are at high altitudes. You can also expect some amount of snow. A nimbostratus cloud, which is again a mid-level cloud, these are the main rain clouds. Apart from the cumulonimbus clouds, nimbostratus clouds are the clouds which bring rain, which bring a reasonable amount of precipitation. The cumulonimbus clouds bring heavy amounts of precipitation, but nimbostratus clouds are the ones which will bring moderate to high amounts of precipitation for most of the latitudes. So, this is seen worldwide occurrence. You can see it everywhere, and most common in mid latitudes. Okay, that is 30 to 60 degree latitudes. So, they are usually formed from the thickening and lowering of altostratus cloud. We have just seen what is altostratus cloud. From the thickening of altostratus cloud, we can see the formation of nimbostratus clouds. So, precipitation that you can expect from this type of clouds is moderate to heavy rain or snow, which is generally steady and prolonged. So, this type of clouds generally give you a lot of precipitation, and this precipitation lasts over a very long period of time, right. So, then based on the height, the third altitude or the level is high clouds, which are found at very high altitudes, above let us say 15,000 or 16,000 feet. So, there are three different types of clouds which can be seen at these heights. They are cirrus, cirrocumulus and cirrostratus. So, in the primary classification, again I am telling you, in the primary classification we have seen how these names mean a particular type of cloud. So, for example, cirrocumulus clouds are usually a transitional phase between cirrus and cirrostratus clouds. They can be seen everywhere between 16,500 to 45,000 feet. They are mainly composed of ice crystals. They are at very high altitude, so it is natural that they are mainly composed of the ice crystals. And cloudlets formed by choppy winds and high moisture levels in the upper troposphere. So, this will result into this type of process, right. Now, the other type of high level high lying clouds is cirrostratus. They are formed by spreading and joining of cirrus clouds. They are mainly delicate cloud streaks that you see during the formation of halo or something like that. They are high level clouds. That means they can be seen worldwide at very high altitudes, 20,000 to 42,000 feet. Composition is mainly ice crystals. That is how it results into this, let us say, the formation of halo. And precipitation is none. Since they are at very high altitudes, they won't precipitate, and even if they precipitate, that would never reach the surface and produce of various effects, various optical effects in the upper atmosphere, such as halo and these things. Okay. Then other important type of cloud which is not relevant for the precipitation or for the moisture or for the phase transitions, stuff like that, they are called as the Noctulucent clouds. They are the most brightest and the magnificent clouds that we can see from the earth. The highest clouds, they are not in the altitude ranges that we have defined for identification of clouds or for classification of clouds. They are typically from 75 to 85 or 90 kilometers altitude. There is still a lot of research that is going on to understand the formation and the effects of Noctulucent clouds. They mainly contains of water ice. They can be seen only in deep twilights. Twilight is a period of time when the sun is below the horizon, and still you will find illumination. And they are very difficult to spot. They are very difficult to identify, or they are very difficult. The sightings are very rare, and they occur only between 50 to 70 degrees north and south of the equator. So, they are the clouds which will form in the high latitudes. High latitudes. High latitudes are generally 60 to 90 degrees, right. So, you see this, the formation is not totally understood. We do not know much, or we do not know completely the formation mechanism of these type of clouds, but they are the brightest, or they can be easily seen with the brightest and magnificent occurrence, right. So, this kinds of completes the morphology of the cloud formation. I mean, in how many different ways you can identify the cloud, or looking at the cloud, what can you say about its precipitation chance, things like that. So, I suppose with this understanding you will be able to just out of the window, if you see, I suppose you must be able to understand, or you must be able to tell what is the name of the specific type of cloud that you see out of your window, right. Then if you put all of them together, let us say, so this is how it looks like. So, cloud is just a mass of floating water droplets or ice crystals. Always remember, when cloud is just a mass which has tiny droplets of ice or some ice crystals, right. Now, clouds result into the formation of rain only when the droplets inside them grow to sufficiently large sizes, and that means when the cloud destabilizes, when the stability is gone, by some mechanism, it will result in the formation of rain. So, what you see in this figure is that the highest altitude is marked at 42,500 feet. So, anything below 6,500 feet was named as low clouds, and these are the mid clouds and the high clouds. Now, so the low clouds are stratus, which are layered, stratocumulus, which are spread, cumulus are the puffy or white, well defined bordered clouds. Nimbostratus is the clouds which will bring precipitation again, and cumulonimbus is the cloud which is spread, of course, across all the altitude regions of the cloud formation heights, and cumulonimbus clouds is the one which brings heavy amounts of precipitation, wind, and so many other things. Right. When you go to the mid-level clouds, you have Altocumulus, Altostratus, and cumulonimbus, of course. And in the high, you have cirrostratus, you have cirrocumulus, and cirrus. Right. So, this is the summary of all the cloud formation heights, various different types of clouds, what is the moisture content that you can expect within these clouds, right. Then we will see what is fog. Fog is also a cloud that is formed not in the sky, rather which lies on the ground. So, fog is not to be named as not to be understood as a different mechanism, rather it is the same, it is actually a cloud which has formed on the ground, right. Now, if you look back, the basic idea of the cloud is that when you cool an air parcel, you are reducing its ability to hold water, or you are reducing its ability to contain more amounts of water. That means you are bringing the saturation point to lower limits. That means whatever the amount of saturation that it had is now enough to have supersaturation case. So, when the supersaturation happens, when you exceed the saturation limit, it immediately results in the formation of condensation, and condensation requires some amount of nuclei around which the droplets will form. When the droplets form, you see a cloud, that is it. So, when the moisture condenses, you will see a cloud. When the moisture condenses, it will also release some amount of latent heat into the parcel. That is a different thing, right. Fog generally forms when air saturates, when its relative humidity reaches around nearly 100%, and the water vapor within the air mass condenses, or small particles in the air to form the cloud droplets. So, the water vapor condenses on the small particles and results in the formation of cloud droplet. The air may become saturated either. So, now we have also seen the air may become saturated either by lowering its temperature to the condensation point, or by adding more amount of moisture physically. You can do both of them, but generally adding more moisture is not the mechanism that works. Generally, when the air parcel rises, its temperature is decreased because it is within the tropopause, right. So, you are decreasing the temperature and you are bringing the point of saturation to a lower level of moisture content, right. So, what you see here, so there are actually different types of fogs that you see, that you must have encountered, okay, in the sense that fog can form under a variety of conditions. Okay. Generally what I have, heat radiating from the surface at nights cools the bottom air until it reaches saturation, right. Further radiation cooling at the top of fog layer deepens it. So, generally during the winter season, the ground is cooled to a very low temperature. Now, if there is an amount of air that is just above the surface or above the ground, now when the ground cools to a very low temperature, obviously the air that is in contact with the ground also cools down. So, when it is cooling down, obviously the same mechanism repeats itself. When it is cooling down, it leads to the condensation, and condensation results in the formation of tiny droplets of water. The collection of these tiny droplets of water is the fog in this case, not the cloud. We call it as fog because it is nearer to the ground, right. So, fog forms first at the surface, thickening as cooling continues. So, as this cooling process continues, the fog thickens. This type of cloud that's formed due to the radiation is called as the radiation fog, generally forms when the air near the surface cools to its surface saturation temperature due to the cooling by radiation at night when the sun has set. Okay, so you must have seen this type of cloud, this type of fog nearer the surface near the ground, but the thickening happens as it radiates more and more amount of heat out, right. The other type of fog is called as the advection fog. Advection fogs are the ones which are formed when air moves either over a cooler surface or over a warm moist surface, and as a result the air mass reaches saturation. So, if you see this figure, what is happening is air is moving in this direction. So, air is at this point air is warmer. So that means air is warmer means it has more ability to hold moisture. So, right. So, warm and moist air moves over a cooler surface and its temperature drops. So, it is suddenly encountering a surface which is cool in nature. So, suddenly the temperature of this air mass decreases. When the temperature of this air mass decreases, suddenly it reaches saturation. Since the air is moving, so advection fog is generally formed at a point which is not cool, rather due to the movement the fog is formed here. Right. So, most often this occurs when moist air mass moves over a cold surface such as a large cold body of water or snow or ice cover whose temperature is below the dew point. So, the dew point is always the criteria for the condensation to happen, or of the advecting air mass, dew point of the advecting air mass, and its lowest reaches are cooled to condensation. That means the lowest reaches which are in contact with the cold surface will get to the point of condensation and result in the formation of clouds, or in this case we call them as fog, right. So, what I mean is air mass which is traveling from which is going from one point to other point. Some point it may encounter a very cold surface such as water or ice. Suddenly it becomes cool there, it saturates and results in the formation of a cloud. The other type of clouds are the upslope and valley fogs, are two special cases of advection fogs, particularly to a hilly terrain. They form when air moving in hilly or mountain terrains cools to condensation. So, let's say, so upslope fog, let's say hot and moist air is traveling from this direction. So, as it travels towards a hilly or terrain which gives the advantage of height, as the air rises, now the air is moist, it has not reached the saturation, but when it travels across this slope, its height is increased, right. It is lifted, of course. As it rises with the terrain, it cools to condensation temperature. So, as it is lifted, its temperature is of course cooled, and at some point it can form a cloud, but this happens across the terrain. I mean, it's not a mechanism where you are lifting the air parcel and this air parcel that has been lifted goes to a height and then forms a cloud. Rather, this cooling happens as it is lifted across the terrain. So, that is why you call them as the upslope fog. And the valley fog is another type of fog, as you see in this picture. So, there is an air mass here. Air cools at higher elevations. Now, as it cools, the density increases, of course. The density increases. So, it has the natural tendency to occupy low altitudes, right. So, then this elevation also supports this. As it cools at higher elevations, it forms, it cools and it condenses near the valley, whereby you see a particular type of cloud which is called as the valley fog. So, cold air drainage reduces the air temperature in the valley to condensation point. Okay. So, the cold air is draining across the valley to a low point where it condenses and forms what is called as the valley fog. So, how many different types of fog that we have seen? We have seen a radiation fog, in which generally the radiation that is lost creates certain type of cooling mechanism over which fog has resulted. Then we have seen advection fog. Advection fog is the one in which forms due to air advecting from one point to another point. Within that, this following the same process, that means air mass moving from one point to another point, in between it encountering the condensation, you have also what is called as the upslope fog and the valley fog, right. Then, so this is another type of cloud, advection fog. In this fog, off the coast, a cold ocean current cools the air to its dew point temperature, allowing condensation to happen. This cooling of air created this fog. Let us say this is the picture that you see. So, this fog is just because of the cold current, ocean current, which saturates the air that is above the ocean, right. Now, if you look at the basic mechanism of the cloud condensation, what you can understand based on our elementary understanding of the phase transitions. Now, in the atmosphere, we can always see water to be existing in all its three different phases: water, liquid water, ice crystals, and the vapor, water vapor, right. Now, if you look at the phase transitions, vapor to liquid or liquid to vapor, liquid to solid or solid to liquid, vapor to solid or solid to vapor. The phase transitions from the left to right that you see, you have all the phase transitions listed here. The phase transitions from the left to right are the ones which result in the increased molecular order. That means, if you take a vapor and if liquid arises from this vapor, that means vapor transforms its phase to liquid, then that means that it has resulted in increased molecular order. That means that for the increased molecular order, they must overcome a strong free energy barrier naturally, right. These phase changes do not occur at thermodynamical equilibrium. For example, water droplets are characterized by strong surface tension forces. For a droplet to grow by condensation from vapor, the surface tension has to be exceeded by a strong gradient in the vapor pressure. So, as the droplet grows, it has to grow at the expense that there has to be a gradient in the vapor pressure. Now, saturation is equilibrium saturation when the rates of evaporation are equal to the rates of condensation. If you consider a droplet, if a molecule has to escape this droplet, it has to cross the surface tension barrier. So, saturation is some equilibrium point when the rate of evaporation is equal to the rate of condensation. Now, since there is a free energy barrier, phase transition does not occur at the equilibrium saturation of bulk water, right. Vapor, the pure phase, when cooled adiabatically to equilibrium saturation, should not give droplets. Purest phase of vapor without any impurities or without the presence of any foreign nuclei which can absorb water will never result into the formation of droplets even when the relative humidity reaches 100%. This can only happen, the formation of droplets can only happen if the relative humidity reaches several 100%, right. So, but we have seen that how does the droplets form immediately when the relative humidity reaches just 100% at the lifting condensation level, right. So, the point is, if you have purest phase, that means no impurities, in that particular phase you will not encounter the droplet formation even if the relative humidity is 100%. That means the vapor, the gas, or let us say the vapor is entirely water vapor, then you cannot expect water droplets to form from the vapor phase, right. Then the question is, how do we expect droplets? How do we actually see the droplets to form immediately when the relative humidity has reached 100%? Where does this happen? This happens at the lifting condensation level, right. So this process is called as the process in which droplets form out of the vapor is called as the nucleation, right. So random formation of new embryonic phase within the supersaturated parent phase is called as the nucleation. Again, the random formation of a new embryonic phase within the supersaturated parent phase is called as the nucleation. This is generally a first order phase transition and always associated with a latent heat. That means heat is given out or heat is taken. Right. Homogeneous nucleation is one process, is a type of nucleation. Homogeneous nucleation is the one without the aid of the foreign nuclei, foreign phase. Phase transitions that occur at random locations within the parent phase without the presence of a foreign surface. Example, the cloud droplets forming directly from the vapor phase. Directly from the vapor phase without the aid of any other foreign substance. Homogeneous cloud droplet nucleation requires several 100% supersaturation. So generally we always take it to the point of 100%, then we expect saturation, and then we expect condensation, then the droplets, right. So in the presence of a soluble cloud condensation nuclei, no real nucleation process is required to form cloud droplets. And cloud droplets can form close to equilibrium saturation with the help of cloud condensation nuclei. This process is called as the heterogeneous nucleation. So which is the formation of new phase is the liquid phase here, on a foreign surface, which are insoluble aerosol particles, right. Now how does this mechanism? So many different types of cloud condensation nuclei are present in the atmosphere. They are always there, right. Some becomes wetted, I mean they at relative humidity is less than 100% and account for haze that impedes visibility, right. So below the dew point itself, sometimes, many times during the winter, this particle absorbs the water vapor and results in the formation of tiny droplets, which we generally call as the haze, which really impedes visibility, right. The relatively larger condensation nuclei are those which may grow to cloud droplets. So cloud droplets are small, of course, but when the cloud droplet grows beyond a particular size, you call them as the rain droplets. That is a different story, right. So when the moist air rises by any forced lifting mechanism in an adiabatic ascent, the relative humidity reaches 100%, and the hygroscopic nuclei then begin to serve as the centers of condensation. What is hygroscopic? Hygroscopic is the nature to attract water or to get dissolved in water. Hygroscopic nuclei then begins to serve as the centers of condensation, right. Now if the ascent continues as it is, the supersaturation is produced by the cooling and is depleted by the condensation on nuclei, right. The air with a relative humidity of nearly, let us say, 1 or 1.5% is said to have a supersaturation of 1.5%. Generally in the clouds, there are enough nuclei to keep this percentages lower than 1%. So the cloud droplet or the cloud condensation nuclei won't even allow a relative humidity of 101 or 102%. So they will always keep the relative humidity or the excess or the supersaturation percentage lower than 1%. As the cloud continues to rise, its top will be cooled to temperatures below 0 degrees Celsius, because we have seen in troposphere how much is the lapse rate, and starting from, let us say, 28 or 20 degrees Celsius on the ground, the temperature reduces to 0 degrees sooner. So depending on the presence of ice nuclei, the supercooled droplets may freeze, because if the temperatures are below the freezing point, the vapor will transform, there will be phase transition from vapor to solid phase, resulting in the formation of ice crystals. So, as an example, in the absence of ice nuclei, for pure water, homogeneous freezing does not occur until minus 40 degrees. So, there is a difference. So, if you are rising just at 0 degrees Celsius, vapor will become ice crystals with the help of ice nuclei. If you do not have ice nuclei, the temperature should at least go up till minus 40 degrees Celsius. So, the cloud is an assembly of tiny droplets numbering nearly 100 per cc cubic centimeter and with a approximate radius of 10 micrometers. Right. Then now the cloud structure, the vertical structure of the cloud is extremely stable and the droplets show very little tendency to come together and grow. So, given the density, the number of cloud droplets within the cloud and with this radius, we say that the cloud structure is extremely stable and the droplets show very little tendency to come together and grow. So, if you want to destabilize, so precipitation is developed. So, now one important point that you should understand is that the cloud structure is extremely stable. It will not allow the droplets naturally do not have the tendency to come together and grow. Okay. So, precipitation is developed when the cloud becomes unstable. Only when the cloud becomes unstable, like I said, the precipitation is developed. When the cloud becomes unstable, the droplets may grow at the expense of other droplets. There are two mechanisms by which the cloud becomes unstable. They are collision and coalescence, one mechanism, or interaction with droplets and ice crystals. Right. So, these are the mechanisms by which the cloud will eventually result in the formation of precipitation. Right. So, we will learn about these two mechanisms and how we can quantify the rates at which these two mechanisms will work towards the formation of cloud and many other things in the subsequent classes. Okay, thank you.